Real number system vocabulary. How can you be classified or grouped? Well, first, you're a Mesquite ISD student. We have about 40,000 students in Mesquite ISD. So let's go a little bit deeper. You're not only a Mesquite ISD student, but you also attend Fraser Middle School. In Fraser Middle School, we have about 1,200 students. So let's go a little bit deeper. Not only are you at Fraser Middle School and a Mesquite ISD student, but you're also an 8th grader. We have about 400 8th graders on Fraser Middle School campus. So let's go a little bit deeper. Not only do you go to Mesquite ISD, attend Fraser Middle School, you're in the 8th grade, but you also are the one and only you. When we classify things, we can group them multiple ways. But when we classify numbers, we try to get as specific as possible. Hence why we have 4 groups here. 1, 2, 3, 4. You are still an 8th grader. You are still a part of Fraser Middle School. You are still in Mesquite ISD. But if you notice, there are other people in those groups as well. That's why there's outside space. But what you're not is a Dallas ISD student. Okay, notice how this group is not attached. Today we're going to be classifying numbers, and we're going to be using a visual just like these that we just saw. We're going to classify numbers in the real number system. All numbers are real for us in 8th grade mathematics, but we group them based on what they have in common, such as rational numbers, integers, whole numbers, natural numbers, and then irrational numbers. Just like our grouping with you, there are other numbers attached, but the ones on the inside are included. Okay? So, Ms. Calco, that was confusing. So let's go a little further. Let's actually try it out and find out what these vocabulary words mean. Natural numbers are as specific or as small as we can categorize our numbers. Natural numbers are positive whole numbers. These are numbers that can be used when counting things in nature. Some of our examples would be probably 1 T-Rex, or 2 dinosaur eggs, or also 739, 24,859. These are all numbers, right? But we also include the numbers that Elmo taught us on Sesame Street, our basic counting numbers 1 through 10. So for example there, we use the number 4 also. Now there are lots of numbers in here, but remember they have to be positive whole numbers. If we want to add numbers to our group, we go into whole numbers. Whole numbers are all of the natural numbers right here and the number 0. The number 0 is included as a whole number and not a natural number because we don't naturally teach children how to count starting at 0. We don't go to an open parking lot with no cars and say, okay, Timmy, how many cars in the parking lot? And then yell at them 0. We don't normally start counting that way. So our whole numbers are another step up. It includes 0 and every single natural number in there. Then we go even further into integers. Integers includes all the positive whole numbers, all the natural numbers, and their opposites, aka the negative numbers. Examples could lead to negative 12, negative square root of 16. Square root of 16 breaks down to 4, so it ends up being negative 4. And then negative 4 over 2, 4 divided by 2 breaks down to 2, so it becomes negative 2. Integers, again, includes the whole numbers and the natural numbers because they're inside that circle. Our next group is called rational numbers. Rational numbers includes integers, it's inside, includes whole numbers, includes natural numbers, and any other number that can be written as a fraction. It also includes numbers with decimals that terminate, aka stop, or decimals that repeat. So for example, 7 divided by 2. 7 divided by 2 breaks down to 3.5, a terminating decimal. Another example, negative 1.35. Negative 1.35, that 35 stops, so a terminating decimal there, that is. And then we also have 1 and 1/3. 1/3 turns into 0.3 repeating, so a repeating decimal also is a rational number. We also have what are called irrational numbers. Notice that they are not included in our large circle. Irrational numbers are all the numbers that do not fit into these 4 categories. Irrational numbers are numbers with decimals that have no pattern and go on forever. Irrational numbers are numbers with decimals that have no pattern and go on forever. Our examples could be square root of 7, pi, and square root of 145. Whenever we have a square root, it's very important that you type it into the calculator and find out what that square root is. Some square roots give you irrational numbers or numbers with decimals that have no pattern and go on forever. Some square roots could even give you a whole number like that square root of 16. We always try to convert our numbers to see where we can best classify them. So let's practice. Can you figure out where these numbers go? Pi. Where would we place pi? Pi is an irrational number because it ends with a decimal that keeps going forever and has no pattern. Negative 1/9. Well, 1/9 is a fraction, and it is a negative fraction. It repeats, so we're going to place it as a rational number because it's not a whole number, so it can't go in. So it's stuck out as a rational number. 5/9. 5 divided by 9 is also going to go into our rational numbers because it's not a whole number, and the fraction or the decimal does have a pattern. 3 squared. 3 squared converts into 9, which is rational, it is an integer, it is a whole number, and it's also a natural number. I always try to push my numbers in as far as possible. 1,781. It is rational, it is an integer, it is a whole number, it is also a natural number. Negative square root of 65. Square root of 65 is not going to give me a whole number. It actually gave me a decimal. So it automatically goes to an irrational. Square root of 121. It reduces to an actual whole number. So I'm going to go all the way in to a natural because it reduces to 11. Negative 34. Well, it is rational, but it's also a whole number. It's the opposite of a whole number. So it's going to be an integer. 4.3 repeating. 4.3 repeating is going to go as a rational number because it's got a repeating decimal. All right. Thank you guys for learning our real number system vocabulary, and good luck on your next assignment.